Okay, I felt like recording myself for this. Today, I'm going to be talking about Lagrange multipliers. Right up here, if you can even see that. I'm going to move this up more. Lagrange multipliers. So, this is a topic in multivariable calc, and essentially what it is, Lagrange multipliers is just a way to find maximum and minimum values of a 3D function f given a constraint equation, okay? So Lagrange multipliers are a way to find max and min equations of a 3D equation f given of f with a constraint equation G. Right? So what this will look like, what this will look like is a very simple equation. I'll write it big for you right here. Gradient of f equals the lambda times gradient of G. Yeah, you can like sort of see that. It's kind of really light though, so I'll switch colors. But essentially, we know that gradients are vectors. Gradients are vectors that point in the direction of the most growth, right? So say we just have like a regular 3D like blob. Gradient vector is like always gonna point in the direction of most growth, okay? The biggest growth of x. Okay. So, essentially what this looks like when we're talking in 3D functions, gradient f, x, y, z equals equation lambda, sorry, not an equation, but just lambda times g of x, y, z. Okay. Now, usually you have to assume that these extreme values exist and the gradient of G is not 0. So we have to assume that these values exist, that the extreme values exist, and that gradient G never equals 0. Oops, I also forgot the gradient. Anyway though, let's go ahead and dig into a problem. Wait, actually I just realized. So another thing that's important are these equations. When you're gonna find the extreme values, you have like 3 unsolved variables basically to find the max and mins of your function f, right? So the unknown variables that you're gonna have are x, y, z, and lambda. So to find these equations, to find these variables, the values of these variables, you're going to use these. Your partial derivative x is going to equal lambda times partial derivative of g with respect to x, right? And it's just like that for every other one as well. Partial derivative of f with respect to y equals lambda times partial derivative of g with respect to y, right? Partial derivative is f with respect to z equals lambda times partial derivative g with respect to z. Okay, and those are little equations we're going to be using to find the values of lambda and then eventually x, y, and z. Okay, I've got the equation set up here. I've got the question set up here, and this is going to be my first time running through this question. So we'll see how well we get it right. So we have the function x do f x comma y equals x times e to the negative y. Is our function, just positive y. And our constraint is x squared plus y squared equals 2. Okay. these are our constraints. X squared plus y squared equals 2, and then we want to find the extreme values of this function subject to this constraint. So what we have to do is, like I said earlier, like I just said in the previous segment of that video, you're going to be using partial derivative of x equals lambda partial derivative with respect to g, and partial derivative f with respect to y equals lambda partial derivative of g with respect to y. So let's just go and do that real quick. Fx equals e to the y, and fy equals what was it? Oh, just x e to the y. So, is that right? Yeah, because derivative y is just gonna be 1. Okay, so after that, let's find g. With respect to x, it's just 2x, and partial derivative of g of y, whatever, equals 2y. So now we're gonna go ahead and take that. We're gonna use this partial derivative partial derivative of the function f with respect to x equals lambda times partial derivative of g with respect to x. Okay, partial derivative of x in this case is e to the y. That equals lambda times 2x. Okay. Ooh, so it looks like this is going to be a little bit complicated. Let's see if we can get through it. So that, and then we have f of y, which is, let's go put an and here, and x e to the y equals lambda times 2y. Put that in parentheses. Now we're going to go ahead and solve for lambda. And then I'm pretty sure after that, after we solve for lambda, we'll plug it into some equation of some sort. I'll get back to you right now. Okay, so I figured it out. I don't remember where I left off, but I did erase, so I'll just go like, we know fx, partial derivative of f with respect to x or y equals lambda times partial derivative of g with respect to x or y. So here we go. Fx e to the y equals lambda times g partial x, which is 2x. I'll put that in parentheses, and we know that partial derivative of y, x e to the y equals lambda times 2y. It's a pretty ugly lambda, my fault. Let's put that like that. Right, so from here, we're gonna not solve for lambda. You would think you would solve for lambda here, but you're not gonna do that. You're gonna solve for the variables x and then y. Because once you do that, you can find lambda, right? So what we'll do here, what we can do here is solve for equation. Okay, so after looking it over, I figured out what we do here. This is correct, but now we are gonna not find lambda, but we're gonna try and eliminate lambda, is essentially what we're doing. So we know that, we'll use this equation. So we know that e to the y equals lambda times 2x. We could just say lambda equals e to the y over 2x. And we plug that in. We'll go ahead and say that x e to the y equals e to the y times 2x times 2y. Now after doing some math, we'll go ahead and just say that oh yeah, so we could divide these over, right? We'll have x equals e to the y 2y over e to the y 2x. Now, if you notice, you can just cancel some of these out, right? I get a red marker. Goodbye, e to the y, goodbye. Goodbye 2, because those cancel out. So what we're left with is x equals y over x. We just rearrange. X squared equals y. Or we don't even rearrange, we multiply it over. So x squared will equal y. Now that we have that, we're going to go ahead and plug that into our constraint equation. Now that we have a value of x or y, we can plug it in. So x squared plus y squared equals 2 turns into y plus y squared equals 2. Now from there, we're going to go ahead and... Okay, yeah. So right here, it looks pretty confusing. You're probably thinking like, what do I do? Shit, I don't know. What you do from here is you subtract the 2 over, and you'll get y squared plus y. We'll just rearrange that, who cares? Minus 2 will equal 0. What do I know that could help with this? Oh, the quadratic equation. So, you know our a equals 1, and b equals 1, and c equals -2. Plug that in, we get -1 plus or minus square root of, what is it, just 1 minus 4 times 1 times -2. So it's just going to be 1 plus 8 over 2 times a, which is just 1. So essentially we're going to get -1. We're going to get, y equals -1 plus or minus square root of 9, which is just 3 over 2. So our y values are going to equal, let's see, if we have -1 minus 3, that's -4 over 2, which will just be -2, or y will equal -1 plus 3, which is just 2 over 2, which is just 1, right? Those are our critical points for y. Now that we have those, we can, let me see if you guys can see this. Yeah, we can find our x coordinates now. So we'll just go ahead and use that x squared equals y. We know that, oh wait, can we? Let me double check. Okay, yeah, so after checking, we're gonna use that equation like I thought. So we'll use y equals x squared, or x squared equals y, whichever you care about. And we'll use 1 first. So x squared equals 1, which means that x will equal either positive or -1, right? Because if you square root 1, it's just gonna be 1. So positive or -1. Now we can try, let's go for it. Y equals -2, or y equals -2. So x squared equals -2. If you try to square root a negative, it won't work. So no x at y equals -2, or no critical points, right? That's essentially what it's saying there. I'm gonna go ahead and erase this and move on, and then, yeah. Okay, so now that we know we have our points, let's see, are you guys able to see that? There we go. Y equals 1, and x equals plus or minus 1. We can now plug that into the equation, which was x e to the y, right? Well, these are our critical points. Now we're gonna test them. Let's go. So let's test the first case, which is f of 1, 1. This will equal, e to the 1 is just e, so it'll just equal e, and then f of, let's see, -1, 1 will equal -e, right? So those are pretty much the max and min values, right? After we get these values, whatever one is bigger is the max, and whatever one is smaller is the min. So max value of f, of the function f, with the constraint of f is e. Min value of f is -e. And that is it.